All right, nothing is actually wrong with your screen where you see 5.1. It is the next lesson I want to do because this is also something that would help you to solve fractions, and I want to make sure we practice it. So, learn to find the least common multiple, or LCM, of a group of numbers. Write this down along with today's date, and page number, and then we'll see how you did. Or we'll get to your warm-up. All right, I'm bumbling around. Must mean I got to stop making videos and take a little break and go home. So here what I want you to do is find the first 5 multiples of each number. So it shouldn't be too hard. I'll do one for you. It goes 5, then 10, then 15. Yes, you're just counting up. Then 20, and then 25. That would be the first 5. Good luck on 2 through 4. And here are the multiples of the rest of them, the first 5 of each number. Hope you're able to figure those out. What we're going to kind of work with is being able to know multiples and how to multiply up through several numbers. All right, so here's a scenario where you're kind of looking for a least common multiple. So after games in Linda's basketball league, one player's family brings snacks. This week, Linda's family will provide juice boxes and granola bars. I'm there. There's 24 players they got to have snacks for. So you can make a model to try to help you find the least number of juice boxes and granola packs that you need to be able to solve for this one. So you're going to try to work through this problem with me in different ways today. We're going to be looking at the first way of trying to figure out using, word problems. How can you do pictures and stuff to solve this? Then we'll actually break down into trying to use multiples and use more of a mathematical way. So here's the first scenario where you can kind of think of pieces when you buy them, when you go to the store. So English muffins, if you're buying English muffins, they come in packs of 8. And don't get the whole wheat ones, they're not that good. Eggs come in cartons of 12. So if there are 24 students, what's the least number of packs and cartons that you need? It's kind of like doing a ratio and trying to figure out what the ratio is for this. So if we drew some pictures, we would try to draw as many as we need to get up to 24 students. So I found pictures and I just made copies. Here's the muffins in groups of what they are sold in, which are 8s. So I noticed that if I did 1 pack of 8 and I did 1 dozen eggs, I don't have enough. I have to buy at least 2 packs of English muffins. When I do that, I see I have 16, but I still will not be able to fit 12 into 16. So I'm going to buy another 12 eggs. All right, well now I have 16 muffins and I have 24 eggs, so I got to buy more muffins. When I buy 8 more, I find out that I have 24. And now I have 24 eggs. So this helps me to figure out that the number that I need to know for 8 and 12 is 3 packages of English muffins and 2 packages or 2 cartons of eggs are what I need to be able to have enough to make, I guess, English muffins for 24 kids. So this is how you use the least common multiple to solve these. You kind of go up your multiples until you find the smallest one that they both have in common. You can put this example down in your notes if you want, but you don't have to. I am interested to see what kind of drawings you come up with. We'll keep it short and simple. It's your turn now. Dog cookies come in packages of 6 and bones in bags of 9. Woof, woof, woof. If there are 18 dogs, what's the least number of packages they'll get of cookies and bones? I know this problem may be rough, but I think you can solve it. Come back when you think you have found how many of each you need, and the pictures should help you here with this one. Good luck. So you probably noticed that when you bought the cookies, a package of 6, and then you look at the package of bones, it doesn't work. So then you buy more cookies. Now you have 12 cookies and only 9 bones. So you're like, I got to buy more bones. And then you realize, oh, I don't have enough cookies. And you keep buying until you find it. You'll find out that 18, that magic number, means you need 3 packages of cookies and 2 bags of bones. I hope you did really well on that one. Let's move on. Now, what are we working on? Well, we're trying to find the LCM. So let's actually have the definition of LCM, or least common multiple. It's the smallest number that is a multiple of two or more numbers. You could do them for multiple numbers. So we've been looking at a couple of them, and now we're going to actually look at how we can do it mathematically without having to use drawings. Write this down though first. All right, let me show you two methods, two ways that you can solve this. One you may find better than the other, but also, like I showed you with greatest common factor, sometimes two different ways works better for different types of scenarios. So the first method to find the least common method is the list method, where you list out the multiples. So let's say we had to find the least common multiple, 4, 5, and 8. We just start listing the multiples of 4. 4, 8, 12, 16. And 5, you do 5, 10, 15, 20, and you keep going. And 8, you go 8, 16, 24, 32, until you find they all have 40 in common. This one sometimes takes a little longer, but if you think about when we did the muffins and the eggs and we did the dog cookies and the bones, you do a couple at a time so that you're not going on and on and on with one problem, and then you find out that its least common multiple is a really small number. So just making the list will help you find it. Copy this down as an example if you think you need to. Here's the other method. You can use prime factorization. So it's pretty similar to using prime factors to find the greatest common factor. First, find all the prime factors of a number. So for 6, it's pretty easy. It's 2 and 3. For 20, it breaks down to 2 times 2 times 5. So now that once you've lined up all your common factors, instead of finding just the ones they have in common, you're going to use every number eventually, but you first want to line up the ones they have that are the same. So they both share a 2, so we have one row of 2's. There's 1, 3 for 6, but we're going to use that anyways. We then have another 2 left over here from doing the 20 and 5. So now that the only thing they shared was the 2's, we can share those with the least common multiple, because we want to find the least number of prime factors as possible. So we try to pair up where we can. So 2 times 3 is 6, 6 times 2 is 12, and 12 times 5 is 60. So the least common multiple for 6 and 20 is 60. Again, you could find that just by listing all the multiples until you see they both have 60. This may be a faster method. It's up to you. Now that we've gone over two different types of methods, let's actually put into play these with some practice problems that you're going to do. We'll start out with a simple one. Try to find the least common multiple of 2 and 3. This is one where the list method may be best for you. Come back when you're done. All right, using the list method, you probably found that the least common multiple of 2 and 3 is 6. It didn't take long to get to that one. Told you I'd start with an easy one. Now we have 3, 4, and 9. Find the least common multiple. Again, they're 3 small numbers, so maybe the list method is best for you. But if you want to find the prime factors of them, you could do that too. Come back when you're done. And if you did use the list method, you'd find that 36 is the least common multiple. 3 is probably the longest one you had to do, and then 4, you all of a sudden see that you have 36. Just so you know, when I do the list method like this, I do about 5 multiples at a time. That's why I did the warm up as 5 multiples at a time. Okay, let's do another one. Here you have 4 and 10. Use which method you feel most comfortable with. Come back when you got the LCM for these two numbers. So I did the prime factorization method, and I saw that 4 is 2 and 2, and 10 is 5 and 2. So they both shared a 2. Then there was another 2 and a 5, and when you multiply those together, you get 20. Probably the list method would have been fine with this one, but I figured, let's try it. Okay. Last one I want you to take a shot at, 12, 6, and 8. Find the least common multiple of these three numbers. Come back when you're done. For this one, I used the list method because I was able to go through them quick enough. The least common multiple of 6, 8, and 12 is 24. It's the smallest number that, when multiplied, you get for the 3. Okay, hopefully that wasn't too hard. Hope you did well on all those practice problems, because now it's time for your box of thought. So go ahead and take some time and write the best answer you can for explaining why you cannot find the greatest common multiple, and tell whether the least common multiple of a set of numbers can ever be smaller than any of the numbers in the set. That's a good one to think about. Try thinking. I'm basically saying, what's the difference between LCM and a common factor? All right, here's your warm up, or your warm up. I'm really got to be done doing lessons today. Here's your quiz. There's 5 problems. Find the LCM of 1, 2, 3, and 4. And then you're finding the least common multiple of 5, but here you're looking at a scenario. Okay, I hope you did really well. And this ends actually the unit. This was our last lesson. So no more lessons for this unit. Sounds like you'll probably have a test, a work problem, project, whatever I'm going to make you do, but I'm going to have you practice some of these before we move on. This unit was all about building a base for understanding how to work with numbers, like a number theory, before we break into fractions and eventually decimals. Try to build up some of your knowledge before we really get into the meat and potatoes of 6th grade math. And you did a very good job working through this. So we'll see you next time.